Today we're going to start chapter 6, which is about discrete probability distributions. The thing to recall is that discrete variables are numeric, and in particular, these are variables where the possible outcomes are not going to be decimals and they are not going to be fractions. Put another way, these are variables that are countable. So, for example, a discrete variable would be the number of people living in a household, or like the US Census that's happening right now. And so the number of people in a household, you could have 4, you could have 5, you're not going to have 4.2 or 4 3/4 of a person. If you did, that might be kind of a cause for concern, but we're just sort of assuming that these are countable data. You're either going to have 4 or 5. You're not going to have some decimal or fractional amount between those two. So we'll first of all talk about discrete random variables. So first of all, a random variable, that's going to be a variable where we use a capital X or a capital Y, as opposed to just traditional algebra where we use lowercase letters. And so the outcome is going to be dependent on probability, and the outcome is random. So as I mentioned, a discrete random variable, that's a variable where the possible values of the variable are going to be countable, or they are discrete values. An example of this would be like rolling dice. If I roll a standard 6-sided die, the possible outcomes are going to be 1, 2, 3, 4, 5, or 6. I'm not going to roll dice and get 4.8. Continuous random variables, those are going to be the flip side, where you can have decimal results. So if I'm taking a bunch of temperature data from a bunch of medical patients, for instance, one person's temperature could be 98.6, another could be 99.1, another could be 97.3, whatever. That would be continuous. So discrete random variables, some examples of what those might be: the number of defective products, a person's age. If you're over the age of 5, you're not going around telling people I'm 37 and a half. Like, that's not, like, people don't do that. So typically age is considered a discrete variable to most people. The number of people with particular medical condition, variables that would be continuous, height or weight, the time spent waiting online or being on hold, for instance, the lifetime of some component of a machine. When you're talking about a probability distribution, the first step in that task is you would have to list all of the possible values that a random variable could take. So for instance, if you're talking about dice rolling, you would make a list and you'd say you'd have 1, 2, 3, 4, 5, 6. Those are all the possible outcomes that you could have. And then what you would do is you would then list the probability of how often that happened. Now, as we learned before, any individual probability has to be between 0 and 1. And then for a probability distribution, another fact is that all the probabilities of each and every one of your events should also add up to 1. So like if I've got, if I'm just doing like a heads tails kind of probability distribution, so one result will be H, the other result will be T. The two probabilities together should add up to 100%. If I have 60% heads and 50% tails, that's a problem because the total is 110%. I know in sports they like to say they're going to give 110%, but from a mathematician's point of view, that's not a thing. All right, so let's look at some examples here. So we're going to decide if these are probability distributions or not, and then offer some justification. So here, part A, we've got all these outcomes, 1 through 7. Okay, that's fine. You got all these different probabilities, nothing suspicious. And then, oh, look at that. That is a negative probability, my friends. No sirree, Bob. You cannot have negative probabilities. You have a negative probability is not a thing. Like, that's not, like, who does that? Like, that's not, like, no. What? So no negative probabilities. No, bad dog. Get a newspaper and rub your nose in it. No negative probabilities. Okay, anyway. Let's see. What do we have for this next one? So these numbers look legit. You know, there's nothing suspicious going on here. Let's add them all up and just make sure that 0.2 plus 0.2 plus 0.1 plus 0.1 plus 0.15 plus 0.2 plus 0.05. Yeah, those all up. And yes, indeed, they all add up to 1. So that is a good sign. That is what is supposed to happen. So yes. So they all add to 1. Please do this with the actual probabilities. I had a student take a test where they added up like all of these numbers and then told me whether or not they added to 1. And I'm like, no, bro, that's not how this works. So just make sure you're adding like the actual probabilities, not the list of possible outcomes. All right. Next up, this one, everything seems legit. Nothing terribly suspicious going on here. You got some decimal values between 0 and 1. That's fine. Let's just see what they all add up to, shall we? 0.1 plus 0.1 plus 0.25 plus 0.3 plus 0.05 plus 0.05 plus 0.1. Well, that's interesting. These only add up to 0.95. That's a bit of a problem because all the probabilities are supposed to add up to 1 or 100%. So this is going to be no. And the reason is they don't add to 1. It's going to take me a lot longer to write it with this stinking mouse than to just say it. Don't add to don't add to 1. That would be the reason. So all your probabilities got to add up to 1. All right, so individuals in the community are surveyed about how many times they donate blood. X is the number of times they donate blood. And so for a randomly selected member of the community. And so this is a probability distribution. Find the probability that X is equal to 3, okay? Well, that just means we're going to look at where the X value is 3. That's going to be this one right here, which is 0.1. So you say, all right, the way this is written, you would say P of X equal to 3. That would be the notation for this. And then you would say that is equal to 0.1. That's just the probability that goes with that value. So there you go. That would be your answer. What's the probability that X is less than 3? So that would be written this way. Probability P of X less than 3. And you notice it strictly says less than. It does not say it can equal 3, just that it has to be less than 3. Well, what do we have here? So the one's less than 3. You've got this one, and that one. If you add up 0.25 plus 0.25 plus 0.3, that is a grand total of 0.8. So the answer to this one is going to be 0.8 if you add all of those values up. Find the probability that x is greater than or equal to 2. So the way that would be notated, you'd say P of x greater than or equal. Let's try to make that a little more straight. Greater than, oh my gosh, this mouse is driving me nuts. All right, greater than or equal to 2. There we go. All right. So greater than or equal to 2. So we're including 2. Boop, there you go. There's 2. And then everybody bigger than 2. So we got this one, this one, this one, and that one. And if we add all those up, let's just see what we have. 0.25 plus 0.1 plus 0.05 plus 0.03 plus 0.02. That gives you 0.45. All right, so the grand total of all of those is 0.45, also known as a 45% chance of picking someone who donated 2 or more times. Okay, this one, we want the probability x is going to be greater than 3, so 3 is the low end. So that's another way of saying x greater than 3. And then x is also going to be less than or equal to 5. So basically we're saying x is between those two values. We are including 5, but we are not including 3. So that's how you would notate that. Let's see here. So you got to be bigger than 3, which means you do want 4, but not 3. And then you want to be equal to 5, but then that's it. So really that's just another way of saying 4 or 5 is another way of saying that. You add those two values up, 0.05 plus 0.03, that is going to give you a grand total of 0.08 for this one. So there's an 8% chance that will happen. All right, so there's two types of functions that people work with in statistics with probability distribution. So you've got what's called a probability density function, which is called a PDF for short, which is not like the file extension for Adobe, but this is something different. And then there's also something called the cumulative distribution function, which is called the CDF. So we've already seen probability density functions. So like that right there, that example, that is a PDF. It's a probability distribution density function. Now you can also find what's called a cumulative distribution function. You might have seen in like textbooks, sometimes you see the term like a cumulative review, which is basically it's a review of everything up to that point. So cumulative means it's the sum total of everything up until that particular point. So in other words, this is another way of saying it's like a running total, basically. So here is a PDF, and we're going to find CDFs. And so f of x is how we're going to notate capital F of x. We're going to notate a CDF for this chart. So we're going to calculate the following values. So a CDF of 3 is basically another way of saying the probability that x is less than or equal to 3 is essentially what that means. It's like the running total up to 3 here. So up to 3, you've got that one, that one, that one, and that one. So you're going to add those 4 values up. Let's see, that's going to be 0.3 plus 0.25 plus 0.25 plus 0.1. Let's see, those two give you 50. That one's going to take you up to 80. That's going to give you 90. So this is going to be 0.90 is what those will all add up to. Let's not do this in the highlighter. Let's do 0.9 or 0.90, 90%. So there you go, 0.9. The cumulative distribution function for f of 5, that's basically another way of saying the probability that x is less than or equal to 5. And so that's basically going to be everything, this one, this one, this one, this one, this one, and this one. You can add those all up individually. Since there's only one value left, you could use the complement if you wanted to, which is where you do 1 minus the one excluded value. 1 minus 0.02 is going to tell you that the answer is 0.98. Or you could, again, just add up all of those numbers individually, and that'll also give you 0.98. But that is the cumulative distribution function, or cumulative density function. Cumulative distribution function for 5. All right, so something else you can do is find the mean or expected value of a probability distribution. How can you do that, you might wonder? I don't know the individual entries. Well, there's actually still a way to do it. So what you would do is to find mu, you do the grand total of the outcome x times its probability. To find the variance, there's 2 ways to do it, where you do the individual value x minus the mean, take all of those and square it, then multiply the probability and find the sum. That's a little bit more cumbersome than doing it this alternative way, which is you do x squared times p of x and then subtract the mean squared. That gives you the variance, and then the thing to remember is that the standard deviation is the square root of the variance. Now, if that formula doesn't make sense to you yet, we're going to show this process in action so that hopefully it makes a little more sense to you of how this works. So here we've got ourselves a table. So we've got a quiz worth 5 points. X is the number of a randomly selected students. Let's see. X is the score. Yes, the score of a randomly selected student. So there's basically 0.05 or 5% of the students scored 0. 12% got a 1 out of 5. 18 got 2 out of 5. 22% got 3 out of 5. 26% got 4 out of 5. And then 17% got a 5 out of 5. All right, so first we've got just kind of problems similar to what we've done before. So what's the probability they got 3 or more? Well, 3 or more, you've got this one, and that one. So if you add up those 3 probabilities, 0.22 plus 0.26 plus 0.17, if you add those up, you will get 0.65. That is that probability. All right, the probability of 3 or less. So again, we're including 3 or everything that is less than that. So we're going to add up all of those values right there. 0.22 plus 0.18 plus 0.12 plus 0.05. That gives you a grand total of 0.57. Switch away from the highlighter, please. 0.57. All right, between 2 and 4 inclusive. So what does 2 and 4 inclusive mean? Well, that's going to be everything from there to there. 2 to 4 inclusives. That's 0.18 plus 0.22 plus 0.26. That is a grand total of 0.66. So inclusive means you do include 2 and 4, as opposed to exclusive, which means you exclude 2 and 4. You don't include them. All right, let's keep on chugging here. What else do we got here? So find the expected value of the score. All right. So here's what we're going to do. Let's actually get a new slide here. And let's see here. All right, so let's copy this table. Oh, hush. You're driving me nuts, computer. All right, here we go. So here's how I like to do this. So we're going to have x over here. We're going to have p of x right here. And then our next column is going to be x times p of x. We're just going to multiply those together. And then after that, we're going to put x squared. Let's try to make that a little straighter here. And then we're going to have x squared times p of x. All right, so what are the x's? We've got 0, 1, 2, 3, 4, and 5. What do we have for the p of x's? You've got 0.05, 0.12, 0.18, 0.22, 0.26, and 0.17. So what's going to go in this column is I'm just going to multiply across here. I'm going to do 0 times 0.05. 0 times 0.05 is 0. And we just work our way down. 1 times 0.12 is 0.12. 2 times 0.18, that's going to be 0.36. 3 times 0.22, that's going to be 0.66. 4 times 0.26 is going to be 1.04. And then 5 times 0.17 is 0.85. And so then what we're going to do is we're going to find a total of all of those that I just found. So all of these values here, I am going to add those up and see what they give me. So 0 plus 0.12 plus 0.36 plus 0.66 plus 1.04 plus 0.85. You add all that up, you get 3.03. And let's get out a highlighter here. There's 3.03. So there's two ways to write that. You could say mu equals 3.03. That means the mean. Or alternatively, this is called the expected value, which is E of x. It's just another way of saying the same thing. The expected value of x, or the mean, is 3.03. So then the other thing that they ask us to do is find the variance of the score. So to find the variance, here's what we are going to do. We are going to square all the x values. So go back here. 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. Let's see. And then 5 times 5 is 25. Now we're going to multiply the probabilities, the p of x's, times the x squared. So that's what's going to go over here. So 0.05 times 0 is 0. 0.12 times 1 is 0.12. 0.18 times 4 is 0.72. 0.22 times 9, that is 1.98. 0.26 times 16. I'm using a calculator, by the way. Don't feel like you have to do this nonsense like in your head. Use technology, please. That's what it's for. That's 4.16. 0.17 times 25. That is 4.25. So now, like before, we're going to find a total of all of those that we just found. So we've got 0 plus 0.12 plus 0.72 plus 1.98 plus 4.16 plus 4.25, and that is a grand total of 11.23. So then here's what you do. To find the variance, which is var of x, you're going to take the total you just found, so it's the sum of x squared times p of x. So that's 11.23. And then what we need to do is subtract the mean squared. Since these are all squared values, we're going to do the mean squared and find out what that is. We're going to do 3.03 squared. 3.03 squared happens to be 9.1809 for those playing the home game. I'll write it over here. That's 9.1809. All right. So if you do 11.23 minus 9.1809, you will get 2.0491. And that is the variance. Please make sure to read the fine print. And if it asks for variance, be sure to give the variance. Some questions might ask you for the standard deviation, which we've seen before, that's sigma. If you are ever asked to provide the standard deviation, you need to take the square root of the number that I just found. Now this example asked for the variance, that's what we're giving them. If you want the standard deviation, you would just have to do one additional step, which would be, that would be sigma is the square root of 2.0491. And so if you wanted the standard deviation, that would be 1.4315. This is the variance that's also sometimes called sigma squared. But anyway, if it asks for the standard deviation, take the square root after that. If all it asks for is the variance, then you're done. Be sure to read the fine print on problems like this. I can't tell you how many times I've had students miss questions where they're most of the way right, but they gave the wrong thing as their answer. And frankly, it's also happened to me too if I'm not slowing down and checking myself. A wise man once said, check yourself before you wreck yourself. I think that was Plato. It might have been the rapper Ice-T. I'm not, it's one of the, I get them all confused. But anyway, so there you go. 2.0491, that's the variance. All right, so you can also use the graphing calculator. So what you can do is in list 1, put all the X values, and then in list 2, put all the probabilities. And then if you go to 1var stats, it will give you the mean and the standard deviation with along the lines of the process that I just showed you by hand. So here we got this guy, Bob. He likes to play poker. He typically plays in 5 poker tournaments. They cost $25 to enter, and if you win, you receive back $100. So X is going to be the number of tournaments he plays. And so then you've got the probabilities for how often he wins, the number of tournaments he wins. And so then they're saying find the expected value of X. All right, so here's what we're going to do. Let's fire up the calculator here. Give me a second. All right, so in list 1, we're going to do 0, 1, 2, 3, 4, 5. Let's go ahead and do that. So get your calculator fired up here. Go to Stat, choose Edit, arrow up to the top, and do Clear Enter to clear out any stuff that's already in there. Clear Enter. So the first list is just 0, 1, 2, 3, 4, 5. That's the number of possible tournaments that our friend Bob can win. Let's see. And then what do we got? 0.45, 0.24. So we'll put those in the first two. So we got 0.45, 0.24. And then what do we have? We've got 0.12, 0.1, 0.12, 0.1, and then we've got 0.06, 0.03, 0.06, and 0.03. All right, so now what we're going to do, we're going to go to Stat. We're going to go over to Calc and choose 1var stats like we've done previously. Here we're going to do things a little bit differently. So we've got our list, which is L1. For the frequency list, we're going to call that L2. So you just do second 2 to get list number 2. So the probabilities are the frequencies, how often they're going to happen. So how often is he going to have that many wins? So then we do calculate. So here it's telling us the mean is 1.17. We've kind of glossed over these before, but so here you'll notice it's got the sum of the x's, and it's also got the sum of the x squareds. So those are like the intermediate values you would use to calculate. So the sum of the x's is going to be the value times the probability, and then this is the value squared times the probability. And so for this example, the mean is 1.17, and then the standard deviation is 1.4, almost exactly. So the expected value of x is 1.17. So our friend Bob here can expect to win basically one tournament. Let y be the amount of money he is going to win or lose after playing 5 tournaments. Okay, so if he wins 0 tournaments, that means he's going to be down $25 for each one. That means that he's going to have negative $125 that he has paid, and he has won nothing. So if he wins 0 tournaments, he will have paid $125, and there is a 45% chance that that is what will happen. If he wins, they pay him $100. So that means that if he has one win, that means this value is going to go up by $100. So he's only down 25 bucks if he wins one tournament and then loses the other 4. And there is a 0.24% chance that that will happen. In the meantime, we keep adding 100 because each time this number goes up, that's one additional win that our friend Bob is getting. So $100 from where we left off. Add that up, that'll be 75. Then you'll have 175. Then you'll have 275. And then finally, it'll be 375. So if he wins all the tournaments, he will have won $500. But since he paid $125 just for the privilege of playing, he's only having a net gain of $375 if he does really, really well. So here we've got 0.12. Here we've got 0.1. Here we've got 0.06. And here we've got 0.03. So now we want to find the expected value of y. So let's go back to the calculator here. We'll go to Stat. We'll go to Edit. And then this time we're going to change list 1. We're going to have negative 125, negative 25. Let's see, 75, 175, 275, and 375. And the probabilities are all the same. So now we're going to go to Stat, go over to Calc, do 1-bar stats again. Still use list 1 and list 2. If you ever go back, by the way, and do questions where you're only doing one column, please, 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 please make sure the frequency list is empty. Make sure if you're using the calculator, if you're not doing a frequency distribution, do not have a list entered in frequency list. Please check that. So if you ever go back to doing other stuff, please just check that. I can't tell you how many times that issue has come up with students I've worked with. So we do this. Now let's see what we got. So this time the expected value is -8. Okay. Oop, that's not what I want. So the expected value is -8. So E of Y equals -8. So that basically means that on average, our friend Bob is going to lose $8. You know, if he likes playing poker, maybe that's not such a bad thing, but he might want to, I don't know, get better or, I don't know, find a different hobby. I don't know. As it is, he's losing money. But hey, if he's having fun and has got cash to burn, then, well, fair enough. All right. Suppose the number of recalls of children's toys during a given month is a random variable whose probability distribution is given in the table below. So find the probability that the number of recalls is greater than 1, less than 3, between 2 and 5 inclusive. All right, so here we're basically just reading the values off of the table here. So greater than 1, well, greater than 1, it doesn't say greater than or equal to 1, it does say greater than 1. So that means we want the chances of 2, 3, 4, 5, and 6. So we want it to be, strictly speaking, greater than 1. 0.15 plus 0.1 plus 0.1 plus 0.05 plus 0.05, and you add that all up, and you get a grand total of 0.45. All right, the number of recalls in a given month is less than 3. So less than 3, it doesn't include 3. Here's 0, 1, and 2. Those two give you 30. That's another 40. So this one, the answer is going to be 0.7 or 0.70, if you will. The number of recalls is between 2 and 5 inclusive. You notice it says inclusive, so we're going to include 2 and 5. So here's 2, 3, 4. We include 5. Add those all up. 15 and 5 is 20. 10 and 10 is also 20. That's a grand total of 40. There's a 40% chance that the number of recalls will be between 2 and 5 inclusive. Okay, so now they're saying, here's the same random distribution, find the mean, find the standard deviation. And then we got this other question here, but let's bust out our calculator here. So we got 0 through 6. So let's go to stat, edit. So we're gonna have 0, 1, 2, 3, 4, 5, 6. And then let's see here, go back to the top and clear all this. No, go to the top, go to the top, go to the top, clear it, clear. Okay. What do we do? So we've got 0.4, 0.15, 0.15, 0.4, 0.15, 0.15. Then what do we have? 0.1, 0.1, 0.05, 0.05. 0.1, enter, 0.1, enter, 0.05, enter, 0.05, enter. Okay, so now we're going to go to stat, go over to calc, pick the one of our stats. List 1 is the list of outcomes. The frequencies or probabilities is in list 2 as before. If you put them in different lists, please make sure that you use the correct list numbers, but I'm just doing list 1 and list 2 here. What do we got? Hit enter. What's the answer there, almighty calculator? Oh, great and beneficent calculator, we mere mortals humbly beseech thee. Tell us, please, what is the expected value and standard deviation for this frequency distribution? It is 1.7 for the mean. So the mean, that is not the symbol for the mean. That's the mean. What was it, 1.7? I think it was 1.7. So the mean is 1.7, and then the standard deviation is 1.85 if you round that off. So that's this thing. Kind of looks like a 6 that's lying down. What was it? 1.8, 1.85. Okay, so that's the standard deviation. If the number of recalls, should we say the total recalls? Anyway, if the number of recalls in a given month is more than 1 standard deviation above the mean, the federal government issues a special warning directed toward parents. Oh, isn't that fun? All right, so what is the probability that a special warning will be issued? Well, let's see. What do we have here? So we do 1 standard deviation above the mean. Well, so the mean is 1.7. And then we're going to add 1 standard deviation to that, which is 1.85. So if we add those up, 1.7 plus 1.85, that is 3.55. So this is basically another way of saying what's the probability that it's, because it's either going to be 3 or 4. It's not going to be 3.55. Benefit of the doubt, if we have to round up to 4, we're asked to find the probability that x is greater than or equal to 4. That is what we are being asked to find. So basically, if this toy company is prone to lots of recalls, parents might want to know that. They might think, maybe we don't need the Tickle Me Elmo knife edition. I've not, it's just a thought, maybe having an actual knife was not a good, or maybe like maybe the demonic murderous Furby was not something we want to get for our kid. Just saying. All right. Anyway, so you want probabilities greater than or equal to 4. So that's 0.1 plus 0.05 plus 0.05. That is going to add up to a grand total of 0.2 or 0.20, 20%. That's a pretty substantial chance of lots of recalls. That's that toy company might want to like seriously rethink like what they're up to over there. Just that seems a little high. All right. Anyway, so what do we got? So we got a quiz here, and we got this probability distribution. This time, you notice we have a missing value. Well, here's what we got here. All the probabilities together, all of them should add up to a grand total of 1. So if we don't know one of the values, if we do 1 minus all the values that we do know, that will give me the value of k. So we're going to do 1 minus 0.05 minus 0.12 minus 0.18 minus 0.21 minus 0.14. And if we do that, that will give us the value of k. So let's find out what that is. Okay. So 1 minus 0.05 minus 0.12 minus 0.18 minus 0.21 minus 0.14. And you do all that and you get 0.3. And then they say find the expected value. Oh, I thought you'd never ask. All right, well, let's break out our friendly neighborhood calculator here. So we're going to go to Stat, Edit. This only goes up to 5. Yes, it does. So we're going to go over here. And let's just delete this guy. There we go. All right, go up here, clear, enter, get rid of all that junk. What do we got? We got 05, 05, 12, and 18. And then what? We've got 21. That was 3 and 14. So we got 0.21, 0.3, and 0.14. Just double check that real quick. Okay. So now we're going to find the expected value. So we're going to go to Stat, go over to Calc, pick our 1-bar stats that we know and love so well. List 1 and list 2 are what we're using. And we're going to hit enter and 3.01. There you go. That is the expected value. So E of X, also known as mu, the mean, that was, I already forgot what it was, 3.01. All right, there you go. 3.01 it is. Da, da, da. There you go. We're rocking. What is this? Jill is a casual poker player. Winning a tournament will pay $500, but joining the tournament will cost $30. She's played many tournaments and figures she has a 7% chance of winning, which means she has a 93% chance of losing. What is the expected gain or value that she will make for playing in a tournament? Okay, well, so here we've only got a single tournament. So we've got X. It costs her $30. And then we've got P of X. And so she'll lose $30 if she loses, and there's a 93% chance that will happen. So there's a 0.93 chance that she will lose 30 bucks. On the other hand, she will get paid $500. However, she's down 30, so she's only going to have a net of 470. Because even though she wins 500, she's still out 30 bucks for the pleasure of playing in the first place. And there is a 0.07%. There's a 7% or 0.07 chance that that she wins. So we're going to find the expected gain or the expected value. So we'll just do this by hand since there's only two values to work with here. So negative 30 times 0.93 is going to give you negative 27.9. On the other hand, 470 times 0.07 is going to give you 32.9. And so then that means our friend Jill here, well, one thing, she's clearly a better poker player than that dude Bob we were looking at. So what do we got? You got negative 27.9 plus 32.9. That means she stands to come out ahead by like $5. Which compared to the other guy where his expected winnings were negative, meaning he'd be losing money, our friend Jill here is... on average, she's going to be making like $5 every poker tournament she plays. So, not such a bad thing. She might want to go into like higher stakes pots maybe to make it worthwhile. But hey, there you go. So that is the end of section 6.1.